Hello guys, in this video I'll be solving the fourth question from today's weekly contest, and here you can read the question. So here you are given two positive integers, low and high. Those are represented in a string, as a string, and you have to count all the stepping numbers in this range, like where you have to count low and high as well, if low is a stepping numbers or high is also a stepping numbers. Okay, and a stepping number is an integer such that, okay, so regarding a stepping number, so it is an integer where all its adjacent digits have an absolute difference of exactly one. Yeah, so the count can be very large. So that's why what we will do is we will modulo 10 to the power 9 plus 7. Okay, here if you have range between 1 and 11, then the stepping numbers will be 1 2 3. Like here there is just one digit, right? So there is no neighbor, so no difference. But yeah, 10 has a neighbor, like here two digits have neighbor to each other, and 1 minus 0 is 1. So absolute difference is 1 only, so it's also a stepping number. Here you have given two numbers, 90 and 101. Between these two you have two stepping numbers, one is 98, one is 101. So between digits of 9 and 8, absolute difference is 1. 1 and 0, absolute difference is 1. 0 and 1, absolute difference is 1. That's why these two are stepping numbers. Okay, so yeah, let's talk about like how we can approach this. So yeah, we can look into the digits, and we can keep making uh, numbers one after another. So before that, let's look into the constants. So here length of those numbers will be till 100. Okay, 10 to the power 100 is the limit for low and high. So minimum value will be 1, maximum is 10 to the power 100. Okay, low and high consist of only digits. Okay, 0 to 9, those things. And then low and high don't have any leading zeros. Leading zeros are not expected. Yeah, good. So you could have 0011 or something 011. Those things will not be there. Okay, so let's talk about like if we can count numbers. So how we can count numbers? Let's find out. So if you just have to look at the numbers of one digit, then you have all these 1 2 3 4 5. So this way you have all 9, right? So all the numbers with just one digit counts 9, right? What I'll do is I'll try to create numbers with certain digits, like, yeah. So or maybe I can create numbers like which have certain like last digits. So if you have last digit at 0, then you can start with 1. Okay, and then you can, okay, then you can, yeah, if you have 1, then you can keep this thing, right? And then other than this you can just write this. Why I am like having leading zero as well, like here why I am including leading zero as well? So this is to make sure that I can find out like the next level of digits, like the numbers with more digits. Like here the number is of just 3 digits, right? To find out number of 4 digits, what I can do is uh, like just for 0 1 0, so I can have 0 1, right? So this can be created with this, right? Like this is having leading 0, but this is not having leading 0, but it is using a number which has leading 0, right? So those things we will keep in our mind. And one more thing, if you are starting, and if you are counting a number of 4 digits, if you are counting a number of 4 digits and that number starts with 1, then after 1 it is sure that you will have either have 0 or you will have 2. So if it starts with 2, like it leads with, like if the second digit is 2, then this value can be 1 2 1 0, or any other possibility 1 2 3 2, or 1 2 3 4, any other possibility 1 2 1 2. This was missing. Okay, so if you have 1 and then you have 2, then these two will be dependent on this 2 value, right? So if 2 is something, if this second digit is something, then these two will be having certain counts, like it will have certain combinations. So like after 2 you can have 1 0, after 2 you can have 3 2, you can have 3 4, you can have 1 2. So if 2 is given, then next 2 digits will be dependent upon this one, right? Otherwise, if you have 1 0, similarly if you have 1 0, then other two digits will be dependent upon this 0 only, right? So other two digit can be 1 2, you can have 1 0, or you can have 1 0. Yeah, I think these two are the only cases. So here we can see that we can create some kind of recursion. Guys, for recursion, I have created this diagram for you. So here, if I'm starting to create numbers with 0, starting with 0, then we will go, we can add 1 after 0, and then we can add 0 or 2, right? Same thing, if I am starting with 1 as MSB, then this is how the recursion tree will look like. So after 1, you can include 2 or 0. After 2, you can include 1 or 3. Again, if you are starting with 2, then you can include 1, okay, or 3. So if you are including 1, then you can include 0 or 2. And this is repetition of the same thing. So here also after 1, you are including 0 or 2. Again, after 1, including 0 or 2. Okay. So the count of numbers where the second least significant digit is 1. If second least significant digit is 1, like after 1, if there is just one number, then the count will be same, right? So this is kind of repetition that is happening if we are doing recursion. Okay, same thing, like if I am starting with, okay, here only, if I have 3 as second digit, okay, then 3 2 or 3 4. So these two are possibilities, and this has been, the same thing has been used here as well. So if I'm starting with 4, then 4 3, and if 3 is second digit, then either 3 2 or 3 4. Again same, 3 2 or 3 4, 2 3 2 3 4 4 3 2 4 3 4. So then now you can understand that you are, you can do this recursion, but if you do this recursion, then you are going to have a lot of time complexity. So the time complexity will be exponential, and that too will be around number of digits, that is 100 to the power 9. Yeah, 100 to the power 10, or yeah, 100 to the power 10 will be the exponential time complexity, since you have 100 digits, right? So I have just shown the tree for 3 digits only. So here you can see the repetition is coming. So what I will do is I'll try to make use of this repetition. Obviously we are like, now we are able to divide this problem into sub problem, like to derive a number of 3 digit. I'll just look for 2 digit. Sorry, I'll just look for 2 digit. Okay, for 2 digit, like we'll just look for 1 digit. So I'll use this sub problem. Like if I have to find out a number, uh, if I have to count the numbers with 3 digits, I'll count the number with 2 digit, and I'll make use of those numbers with 2 digit. And not just 2 digit, obviously I'll make use of the starting digit for a number. Like if my starting digit is 2, then I can make use of it if I am having 3 as the next digit, or I'm having 4 as the next digit. Sorry, I'm having 1 as a next digit. After 2, I can have 1 as a next digit, or I can have 3 as a next digit. After 3, I can have 2 as a next digit, or 4 as a next digit. Similarly, if I am looking looking in reverse, like there are 2 ways you can do recursion: either less significant digit to most significant digit, or from most significant digit to least significant digit. Like similarly, if I am having 3, you can either have 2 or 4, right? So those same thing as like recursion tree is created. So let's go to the implementation part. So and we will see how we can use dynamic programming. So you can pause it here and you can think it yourself, and you can also make like write the implementation. So you can see how I have implemented it. So okay, one more thing. Like here, what I have done is I have counted all the numbers till high, okay, and I have counted all the numbers till low, and I have just subtracted uh, the count till high to the count till low, okay. And since this counting is not inclusive, this will not include high if high is also a stepping number. So what I have done is finally I have included it, like if it is a stepping number, and then I have done modulus, right? So okay, so till now what we have done is we have find out like we have done recursion thing, and with recursion we have created this DP. So you can see how I have created this DP. So here uh, I have just counted for just 1 digit. So it's all the numbers with length 1 has been like found. So you can see that if you have just length of 1, then for every digit you will just have 1 as a count. Okay, so 1 2 3, all those numbers. So this is like I can say DP of 1 comma 3 will be 1 pi, and what will be it? It will just be 3. You cannot have any other thing. So it is for just 1 digits, right? And then for more digits, so for digit for 2 digits to 100 digits, what I have done is I have used the previous length. So like I have used previous length. Okay, so I have calculated for 0 as well. If 0 is my most significant digit, then this thing will be this will be used. So like 1 will be used. So if I have D as most significant digit, then I'll look for D minus 1 as most significant digit for lesser number of digits. Okay, lesser number of digits. okay, just one less digits, and yeah, d minus 1 and d plus 1, these two I'm looking at, okay, and then I'm doing modulus. So finally I have uh, calculated dp of length and digit. So length and digit that I have found out. So this is the most significant digit and this is the length of number, right? So this way I have found out the dp with length and digits, okay, length and most significant digit. But yeah, again, now I have to find out a stepping number till a till a number. So to find out the stepping counts till a number, what we are doing is, first thing is we are counting all smaller length numbers. So if the length is n, if the length of this number is n, then I'll just look till n minus 1. So it's just less than n. So I'll just look for n minus 1. I'll just add all the dp's, like with all like any numbers are starting with any digit but having lesser length. All those will be added in result. And then I'll also find out the same length number, but its digit is, a star digit is a smaller. Okay, a star digit will be a smaller than like a smaller than a star digit. So a star digit here is the actual first digit. So the first digit is like written as a star digit here, and like every digit coming before this will be added. Like if you have 701, like for example, if you have a number as 701 and you have to find out all the stepping numbers like till 701, first what you will do is you will just count all the numbers with lesser digits. Like here the number of digits is 3, so every stepping number with just one digit will be 9, from 1 to 9. And then 2, you will have few numbers like uh, here you will have around 15. I don't know about this, but this will be kind of 1 0 0 1, all these numbers 1 2 2 3 2 sorry 2 1, all these numbers will be counted, right? So here you will have around uh, 7 into 2 14, 14 and 1 15 and 16. I think 16 will be there. Okay, and now for 3 digits you will have all the, for 3 digits, first thing what you will do is you will count for any number starting with 1, any digit starting, any number starting with 3 2, any number starting with like 2 digit numbers. Okay, you have found out 1 digit numbers, 2 digit numbers, and here for 3 digit numbers you will not find out for all, but you will find out for every number which is a starting with less than 7. So 5. And will you look for this as well? No, you will not look for this. So I'm start. So till 6 I'll look if I have to find out all the stepping numbers till 701. Till 6 I have done, and then like one more thing will be important. So again, you have looked till 6, right? But with 7 something something, there can be some, right? So those things will also be calculated. So let's find out not just 6, let's make it as 7 8 1, right? So 7 something something should also be found out, right? So you are sure that you have 7, because till 6 you have already looked up to, till 6 you have just found out. So now the remaining numbers, the remaining counts is all about this 7 something something, right? So to find out all the numbers starting with 7 and of 3 digits, what you will do is uh, you have to also take care of like these things, like that number should be lesser than 781, right? So to make sure, you what you will do is after 7 what you can have the here, like you will check for all the numbers with like, here again like you can have recursion, but not recursion because you will use dp here as well. So with 7 you can either have 6 something, right, or you can have 7 something, right? And now you can see like 7 6 something is like already there. 6 is lesser than 8, right? So it should be included because 6 7 some 6 sorry 7 6 something will always be lesser than 781. So 765 767 any values with 76 will be lesser than 781, so it will all be included. So like this dp will be included, and for this 7 8, so 8 is exactly the number we are having, right? So with 8 with 8 we will not do anything, we will proceed to next number because 8 is exactly the number which I am looking for. So I'll go to next digit. So after 8 we will go for 7, and with 7 I'll find out that I think if this is confusing to you, you can understand that like of 7 8 can be up, can be a stepping number, and 7 8 can like is also the exactly the number which is provided. So after 8 I have to look at if 7 8 can be a stepping number or not. So it's not like after 7 8 the numbers are like these digits are not defined till now, right? So you have to look further. So after 8 you have to look because it is, so even if after 8 you can have 9, right? So 7 8 9 can be possible, but 7 8 9 will be greater, right? 7 8 9 will not, will is not a like valid a stepping number because it's not within 7 8 7, it's not less than a 7 8 7. That's why 7 8 9 should not come here, right? That's why I'll not use dp here. I'll just look for the next digit to like include it or not, right? So I'll go after 7, I'll just find out. So sorry, after 8 I'll find out like 7 8, the two possibilities are there, 7 8 7 or 7 8 9, right? But again 7 8 7 is again matching, so I'll just go for further. I'm not including 7 here because what I have said earlier, like my finder stepping is not counting like inclusively. So if high is a stepping number, it will not count. That's why like my algorithm will just come out of the loop. 787 will not be included because it's exactly like the number that is been provided. So any number lesser than 787 we will be counted, not 787, right? So after encountering 7, it will look for the next digit, but next digit not there, so it will come out of loop, and whatever result has been added as of now will be returned. So you can like now look, you can look into it. So till this I think you have understood. So counting when digit is a star digit is smaller for the same number, same length number, like one something to say like a starting date till any a number starting with 6 till 6, so these are counted, they are counted with dp. Okay, and now with starting with 7 for 787, so there I'm looking for like the first digit. So first digit will be, you can see first digit is 7 only, uh, not 7, it's not first digit exactly, it's second digit because it is 0 indexed. So second digit is 8, and you can see uh, and you have previous digit, and if you're like the next digit should be according to previous digit, right, to have a stepping number. So I'm taking care of like if the current digit is greater than previous digit minus 1. So 7 minus, like if it is greater than 6, so yeah, 8 is greater than 6. So the result will be appended with that DP value. So any number starting with any 2-digit number starting with 6, right? So those things will be done here. And then here, like 9, like here, since previous digit is 7, so 7 plus 1 is 8. And yeah, I think 8 is like here current digit is not more than 8, so it's just equal to 8. So you can see this condition will be satisfied, will be because 8 minus 7 will be, previous digit is 7, current digit is 8, so the solo difference is 1, so it will be satisfied, and previous digit will be updated and it will not break. So yeah, next for the next digit, like now it will come to the third digit from beginning, and for the third digit again, like it will not count here because 8 minus 1 7. So current digit will be 7, but previous digit will also be 8, so previous digit minus 1 will also be 7. So these two will be equal, so it will come here, and again it will do something like it will go to the next digit, and next digit is not there, so it is reached to n, I is equal to n, so it will take, and result will be like whatever DPs and all those things has been appended. And yeah, so if you are counting for 787, then like I think you have understood how you are finding out, or like how you are finding out the count of all the stepping numbers till a certain number. So now I think you have understood how I am returning the result. Thanks a lot for watching. I hope you understood my approach. If you have anything question, anything you want to discuss, please write it in the comments. I'll be happy to answer those. Thanks a lot, guys. And please hit like button if you really like this video, and subscribe it if you find these videos helpful. Thank you.